Welcome to Swarm. If you've ever felt overwhelmed by complex agent frameworks, this is the antidote. Think of Swarm not as a framework, but as a switchboard operator. The client is the operator connecting a user to an agent. If that agent can't help, they don't crash. They just hand the phone to a specialist. Today, we're going to see how this entire logic is built with simple Python primitives. Zero magic. At the heart of everything is this agent class. It's remarkably simple, just a pedantic model. An agent encapsulates a name, a specific model like GPT-4, and instructions. Notice instructions can be a static string or a callable function. This means an agent can dynamically change its persona based on the context of the conversation. Most tools just return strings, but sometimes we need to change the state of the world. We define a result object for this. If a tool function returns a result, it can update global context variables or, crucially, specify a new agent. This is our first hint at how handoffs work. Transferring control is just data passing. We don't want to manually write JSON schemas for every tool. In function to JSON, we use Python's inspect module to read your function's signature. We define a type map that translates Python types like str and int directly into the JSON types string and integer that OpenAI expects. We check every parameter. If a parameter has no default value indicated by inspect empty, we mark it as required in the schema. We then bundle everything into the standard OpenAI tool format using the function's docstring as the description. This automation lets developers focus on writing code, not config files. This is the brain of Swarm. The run method, it initializes the active agent and creates a deep copy of the context variables to keep things pure. We enter a while loop that runs as long as there's an active agent and we haven't hit the turn limit. This loop is the finite state machine. In getSuchHatchy we prepare the system prompt. If the agent's instructions are a function, we call it right here with the current context or variables. This allows the agent to verify a user's account status or check the time before generating its system prompt, ensuring the LLM always has fresh context. This is a clever detail. We convert the agent's functions to JSON. But if a tool asks for context variables, we strip that parameter from the schema we send to OpenAI. We don't want the LLM hallucinating context. We want to inject the real context ourselves implicitly. In handle tool calls, we resolve the function name and parse the arguments. Here is where we inject that hidden state. If the Python function signature includes context variables, we slip the dictionary into the args right before execution. The tool gets full access to the conversation state without the LLM ever knowing. This is the aha moment. When we process a function's return value, we check its type. If the return value is an agent instance, we wrap it in a result and set the agent field. That's it. A handoff isn't a complex framework event. It's just a function returning a new object. Back in the run loop, we process the tool results. We update our context variables with any changes. And here is the switch. If the tool returned a new agent, we update active agent. The loop continues immediately, but now active agent is different. The user never knows the difference. The system just routed the call. In the REPL, we see the pattern in action. We take user input, append it to messages, and call client.run. We pass in the current agent. This means the client application is holding the pointer to who is currently speaking, maintaining the session state locally. After the run completes, we update our local agent variable with response.agent. If the triage agent handed off to the sales agent during the turn, response.agent will be sales agent. The next time the user types a message, it will go directly to sales. The switchboard connection is effectively transferred. Swarm demonstrates that you don't need heavy frameworks to build complex agent behaviors. By relying on two primitives, agents and handoffs, and utilizing the standard request-response loop, we create a system that is transparent, easy to debug, and purely Pythonic. The state lives in the client, and the orchestration is just control flow.